Hey, everybody. Welcome to our day of workshops. We hope that you enjoyed the event yesterday, OpenJS World 2021. It was a really exciting event with so much great content, and I enjoyed it. I hope that you did as well. Thanks to everyone at OpenJS for working with us on this and helping us put this together. Really great to have you. Let's see. So we've got an assortment of workshops today. We hope that there are some that you are really excited about. We tried to pick varied content so everybody had something they could be really excited about. Don't miss the experts panel a little bit later. And if you have any questions for either getting involved in the platform, working on Node Core, or application development questions, we're going to have some experts that are really excited to talk to you. So please, if you have any questions, take note of them and bring them to the session. Also, we have a Slack channel on the OpenJS Foundation Slack org. It is, if you search for workshops or IBM, it'll come up. I think it's OpenJS World IBM Workshops. That's where we'll have all of our comments and questions. So please go there if you want to interact with us. That we'll try to monitor the other chats as well, but that will be the main place to have our conversations for sure. It's a place where you can drop your questions. You can start dropping questions for the expert panel, which is happening later, but you can start dropping questions in there now. We encourage you to be thinking about those things. It would be great to have a lively discussion and get any of your questions answered. A little bit of housekeeping. I just want to let folks know that this stream will not just keep going. So when one ends, you'll have to, pop out and go into the next one. It's kind of easier this way on how the systems work, and I think it'll flow real nicely. And also, I wanted to offer you free clouds. I know everybody loves a free cloud. So if you go to ibm.biz/openjs-workshops-cloud link, you can get a free IBM cloud account. That will be helpful in a number of the sessions today, but I don't think it's and maybe in a couple of them it might be necessary. So feel free to get on there. But without further ado, I want to get right into the content and bring on Beth Griggs. I will let Beth introduce herself and get things started. Thank you, Beth.
Awesome. So hi, everyone, and welcome to the first workshop of the day, which is the Node.js in the Cloud workshop. And it's all about some concepts and tips and tricks for getting started with building cloud-native Node.js applications. So as an introduction, my name is Beth Griggs. I am a senior software engineer at Red Hat, and I have quite a varied role, although a large portion of my role involves contributing to the Node.js project. So I'm an active Node.js community member. I'm on the technical steering committee and also active in a few of the working groups, like the release and package maintenance working group. Some of the other work I do at Red Hat is around enterprise Node.js applications, how to deploy Node apps to cloud, and working with teams internally to find best practices on how they're managing their large-scale Node.js deployments, and also producing tooling and resources to help our customers deploy their apps to cloud. So as a welcome, so the structure of the lab today will be, we'll start with an introduction. We'll go through a short overview of concepts, so like a 15-20 minute primer on some of these concepts that you can listen into. And then we will lead into a self-paced workshop, which touches upon the concepts we've covered. And this will be a self-paced workshop. All the instructions are on GitHub, and you'll work through those. But we will also be available on Slack and Zoom as you're working through those. So if you wanted to join us there, ask any questions, if you hit any issues, you can do that. And what's this workshop about? So it's really good to just overview who's it for. So this workshop's really aimed at developers who are familiar with Node.js but want to gain a base understanding of some key cloud-native concepts. It's going to be an introductory type overview with some neat tips and tricks. The topics we'll cover include some of the key cloud native concepts such as health checking, metrics, Docker, Kubernetes, Prometheus, and Grafana. And the whole workshop will walk you through. You'll start with like a base Express application, which is typical of many folks who use Node.js, and how you would adapt that app and add some features to make it better leverage the cloud. There are a number of tutorial prerequisites for the lab, and that involves installing Docker, Kubernetes, and Helm. So I've just added this link here. It's where the tutorial steps will be. It's github.com nodeshift/tutorial, and then the prerequisites section. If you do not have Docker or Kubernetes installed, it might be worth trying to do that and following those instructions while listening into this talk, just so you're up and ready when we move into the self-paced part of the lab. And with that, let's move on. So what are cloud native applications? I'm sure you've heard the word cloud native thrown around. It's very much a buzzword. And the way I like to explain it is native applications are applications that have been specifically designed with the cloud technologies in mind. So we add features to these applications so they can better leverage the cloud and the cloud technologies. And this means it's not a static definition. What's cloud native? What looks like a cloud native app today will need to evolve to keep up as the cloud technologies and services advance. And with all of these buzzwords that are around, the Cloud Native Computing Foundation has actually started to create a glossary. So if you go to glossary.cncf.io, that has a long glossary of all of the definitions, including a definition for what they consider cloud native to mean. So if you're overwhelmed by all the different words being thrown around, it's good to check that out. So on to building enterprise cloud native applications. So we're really thinking about enterprise cloud applications at this point, because with the cloud and Kubernetes, which is what this workshop is focused on, you're not going to be using that if you've just got a very small single API that you're deploying. This is really when you're deploying large-scale apps that need to be highly available, and apps that are stored in massive clusters with other applications running. So that's really the target kind of applications this workshop is going to touch on. And when you're building enterprise cloud native Node.js applications, there are a number of considerations that you should bear in mind, maybe more so than if you're deploying other types of applications. And one is module and dependency diligence. So everyone knows about node modules and how many there are. When you are building for enterprise and you're building for cloud, it's really worthwhile considering what you're using and looking into it. And also with the enterprise, there are other things you need to consider, like licenses, security issues, maintenance, compatibility, ongoing support of your dependencies. So that's one area where when you're building for enterprise and you're building for cloud, you do need to look into your dependencies. And then you have functional components to consider. So this is considering what web framework am I going to use? Am I going to use something like GraphQL? How will I handle caching? How will I handle authentication and authorization? So those are kind of functional concepts and components you'd need to consider maybe in your cloud app-based applications. Then you have development. So when you're building enterprise-style apps, it's good to have good code consistency, testing, proxying. So really ensuring that your development process is aligning with what you expect your enterprise application to look like. And then you have some concerns around operations. And this is actually what the workshop will touch upon most. And this is around how you can add things like health checking and metrics to your applications so you can better observe what's going on when it's in the cloud. And all of those considerations are actually something Red Hat and IBM are working on. We're working to produce a reference architecture for enterprise Node.js applications. And the way we're doing this is we are getting together folks with expertise in running large deployments of Node.js across the organizations. And we're finding out what they're using today, what they recommend, any pitfalls they've fallen down, and then we're turning our learnings into a consumable document, which we call the reference architecture, which will cover all of the functional concepts and the key concepts of building enterprise Node.js cloud applications. And the intent of it is not to force or tell developers how they need to write their applications, but it's just to recommend some good, sensible defaults that we know the organization's got experience with, they're known to work, and we know work well with the cloud. So onto some of the cloud native technologies. Many of them fall under the Cloud Native Computing Foundation. And this foundation serves as a vendor neutral home for the projects. It's slightly similar to the intent of the OpenJS Foundation, which is the neutral home for JavaScript projects. That's the Cloud Native Computing Foundation. And some of the projects included under the foundation include Cloud Foundry, Docker, Kubernetes, Helm, Prometheus. And it's actually Docker, Kubernetes, and Helm and Prometheus that we'll be going through in this workshop today. So we'll start with Docker, and this will be a very introductory level cover of Docker. So you've got your Node.js application that you've built with all of those earlier enterprise considerations in mind. Once you have that application, you can then start thinking about building it into a container. And when you're building an application into a container, it's most common to use Docker. What is Docker? Well, Docker is a tool designed to make it easier to create, deploy, and run applications using containers. Containers essentially allow you to package up your application with everything it needs, such as libraries, dependencies, and ship it out as one package. Sometimes cited as trying to solve the works on my machine problem. It means you can package up the app with everything it needs and make it portable. And often folks explain Docker they explain Docker as if it's like a virtual machine. There is the main difference between a virtual machine and a container is that rather than creating a whole virtual operating system, Docker allows applications to reuse the same Linux kernel. But it's often explained as being a bit like a virtual machine technology, but there is key differences. And to use Docker, the main thing you need is a Docker file. And I think that's the key to understanding Docker. If you write a Docker file, build a container, and see what it looks like. A Docker file is essentially just a text document that contains the commands to assemble an image. This is a sample Docker file, and it assumes it's a regular Express.js app on port 3000. So it's a good base to start from. Lots of folks are using Express. So this is assuming a common application structure and type. And if we go through that Docker file, we start with the base image. The base image is the Docker official Node.js image, which is Debian based. And it's the Node.js 14 image, which is the latest long-term support version. And with here, you can do like node:14 to get the latest 14 release, or you can tie it to various other tags. You could also tie it to a specific version, but because we're just specifying 14, it will always download the latest available Node 14 image. And then the next step in our Docker file is we run some operating system updates. And then we copy over the package.json or the package lock. So this copies both of them over into the container. The next step is to run your npm install production. And this is just to install your dependencies, not developer dependencies. We don't need any test frameworks, for example, in our production containers. And you have to do the npm install in the container, because if you're developing locally on, say, Windows or Mac, it's likely that you'll be deploying your Docker image to a Linux-based OS. So you need to make sure you do your npm install in the container in a Linux environment, because if there's any native compilation going on, you need to make sure it's compiled for the Linux. So you run your npm install, then you copy your application in. And you may think, why not just copy it all in one? Well, Docker works by building each step up in layers, and you copy the application over after the npm install because of this layering system. By copying it over in this way, you can optimize your build times, because it will only ever rebuild the layers that have changed. So the idea is that you're more likely to more often make edits to your app than you are your dependencies. So if you do it in that order, you can optimize your rebuild times. And then later in the Docker file, we just set some environment variables, for example, production, to indicate it's a production express. And finally, we just call npm start. So that's a base Docker file that you can use to set up a container with Node installed, update it, copy in your package JSON, install your modules, and start your app. So it's a very base level Docker file. And that's quite a large Docker file. This is based on a test app that I built a container for last week. That was actually over 900 megs, so it's quite large. And once you've built your image, it's typical that you will push it to a registry somewhere so that you can reuse it. But we can actually optimize the size of this image using what Docker calls multi-stage builds. So if you see in this Docker file, we actually have two from indications. And this is a good indicator that it's a multi-stage build, because with multi-stage builds, we're actually building two containers. And what we're doing is we're creating a build container, but we'll do our npm install, and then we're creating a smaller production container that we just copy the output into. So as you can see in this section here, we're setting up the second container, and this is using a much slimmer image. So the Node.js and Docker provide variations of the Node.js Docker images. You have a fuller one, which is just the node :14, and then we have a much slimmer one with it's much smaller, it contains less, it doesn't have enough to build. It's slimmed down with the intent that you can just copy all your assets into it, and then you've got a smaller image to ship and deploy. So we use the slim image, and then as before, we just set the ports and start the application. And as you can see, this was from my testing last week, it was down to around 200 meg. So you're saving a lot there by not copying what you don't need into your production container, not copying tooling, etc. into it. And then once you've created your Docker file with the commands you need to build your application, you then just call docker build, you specify the tag of what you want it to be called, pass it to Docker file, and the docker build command will build your image. And if it's the first time you've pulled in a Node image or any of the other images that you're using, it will take a long time because it will be downloading that from the registry. Once you've built your image, you can then run an instance of that image with the docker run command. So in this example, we're doing docker run, and then we specify which ports we want to publish. And the publish ports means that we can access the application from the port 3000 on our laptop, and then just specify the image you want to run. So you build the image, and then you run instances of that image. So that's how you build one container and create that. But often you'll need multiple of these. For high scalability, you won't just want one instance of your application, you'll want many, so that if one goes down, you can leverage automatic restart to bring others up, and you don't have that loss of service. And for that, we use Kubernetes, which is a container orchestration tool. And if you take a look at Kubernetes online, you'll see some very thorough architecture diagrams like this. And this talk is really from the Node.js developer's perspective. We're not going to go into the internals of Kubernetes. The main concept to take away is that Kubernetes is a tool and framework that helps you manage your containers and containerized applications. And it does this by allowing you to do things like service discovery, load balancing, storage orchestration, automatic rollouts and rollbacks, automatic bin packing, so specifying how much CPU and memory each container needs, so you can set limits. Self-healing, so that's related to like the automatic restart. If one container crashes, it will start another one for you. And then secret and configuration management. And that's more around how, if you're managing a large Kubernetes cluster and you have databases and things like that, you'll need some secrets and configuration to manage that. And then we have Helm. So Helm's often used in conjunction with Kubernetes, and it's really a bit like a package manager for Kubernetes. I kind of like to describe it as like NPM of Kubernetes. And it's really a blueprint for your Kubernetes deployment. And the format for this packaging is in something that they call a chart. And a Helm chart is a collection of files that describe your related Kubernetes resources. And a Helm chart is similar concept to a package JSON. It gives you the instructions of what your application needs to look like. And a Helm chart is just made up of a selection of YAML files, and we will be using a Helm chart in the workshop. And really, you'll see many template YAML files within the Helm chart, but there are two files in particular that you care about most. And those are the chart YAML, which describes your application, and the values YAML, which is just how you supply values to the other templates. So with the chart YAML, as you can see here, this is the file that describes your application deployment. So we specify things like the API version, the name, and you can optionally specify descriptions. And then you have the values file, and this is really what passes all of the configuration down to the templates to implement it. And in here, you can specify many things from like how many replicas you want. You can specify your memory limits and things like that. And in the workshop, we will be customizing some of this and seeing how we can change the number of replicas and see that Kubernetes, after changing these configuration values, will then spin up a different number of pods for you. And once you have a Helm chart built and ready, all you have to do to install your application into a Kubernetes cluster is the Helm install command. So you just give it a Helm install, and it will look at the Helm chart, which is your description of what your app looks like in the context of a Kubernetes deployment, and it will install that. So it's a really nice way of making your application portable in Kubernetes. And then we have a concept of health checking. This is another that we'll touch on in the workshop. So when you have multiple replicas or pods of your application, Kubernetes will automatically load balance the requests between the two. So you can see here, HTTP request comes in and it will automatically load balance them for you. But Kubernetes has a concept of health checking. So you can expose a route that informs Kubernetes when a given pod is ready to accept that traffic. So in this case, if the ready route is returning 200, we know that, yes, both of these instances are ready to accept requests, so I will load balance between them. But say it wasn't ready yet, it wouldn't start sending traffic until it got the 200 response on there. And you can also expose, as well as like a ready endpoint, you can also expose a liveness endpoint. And the liveness endpoint will tell you whether an instance needs to be restarted. So in the case that your liveness endpoints are green, everything's happy, the liveness endpoint goes down, we know the application's now not accessible. So what Kubernetes will do is it will see that it can't access that liveness endpoint. It will send a SIG term to that particular instance, which essentially just says, I'm going to shut you down. You then have a small window of time to do any cleanup in your application before Kubernetes will send that particular instance a SIG kill, which will shut down your application and it will take it out. It will stop directing traffic to it. And then, as you can see, in this case, Kubernetes is automatically trying to bring another one up. So when you've specified, hey, I want 2 replicas at all times, the second one of them dies, Kubernetes will be like, you said you wanted 2, I'm going to bring another one up straight away. But as you can see, the ready endpoint isn't quite there yet, so it's not ready to start accepting traffic. And in this case, for example, maybe when your application is starting up, you need to manage some connections or something. So it's not quite ready to receive traffic just yet. So Kubernetes won't start sending any traffic until that ready endpoint goes green, and then it will start sending the traffic through again. So it's really how health check endpoints enable the live restart and reload and self-healing nature of Kubernetes. And if you want to know what a health check would look like, it can be as simple as try sending a request to this endpoint of my Express application. Does it return? Because if you sent a curl request to your API and this route just hung or it just didn't respond, you would know that there's something up in that container and you probably need to restart the app. There are some cases where you may want to do some more intensive checks. So maybe you have within your liveness endpoint, when you query it, it would run some actual checks, like it could check memory limits. But typically we just see the folks just testing, is my API live at this endpoint? And then on to Prometheus. So this is another technology that we touch upon. And this is really around metrics and observability. So what you can do is you can expose a metrics endpoint in your Node.js application. And what happens is the Prometheus tool and client will scrape the metrics from this endpoint and collate them for you. So you tie it all together in Kubernetes. So Prometheus knows in your application, I can scrape metrics from the /metrics endpoint. It doesn't have to be /metrics, it's all configurable, but it's typical for people to call it that. And what this would look like is you could leverage a module, or you could collate those metrics yourself and just host them on an endpoint in a form that Prometheus reads. So in this case, we're using the Prometheus client module, which is from NPM. It's quite a popular one. And we just call collect metrics. And then every time a request is sent to the /metrics endpoint, it will use the underlying implementation of Prom client to scrape some metrics. So things like CPU time, heap size, usage, etc. Spit that out in plain text, and then Prometheus reads that text format and can collate it. And this is an example of what the Prometheus metrics would look like. So as you can see, the top one there, it's just a text value with some numerics. And then once you have all of these metrics being fed into Prometheus, you can then introduce something like Grafana and then pipe all of those metrics into your from Prometheus into a Grafana graph. And what's really nice about that is you can see it across all of the pods. So in this screenshot here, I had 3 pods running. I think it was tracking heap size, and you can see across each of the pods what's going on. So it really helps with the observability, and this is very typical setup of how people would monitor their enterprise cloud-native Node.js applications. So as a summary, that was a very quick introduction to cloud-native development with Node and some key features that you can build into your application that means you better leverage Kubernetes. In particular, the health checks and metrics, but also a brief introduction to Docker and Kube. And with that, we're moving to the self-paced part of the workshop. So the tutorial is available at github.com/nodeshift/tutorial. And what will happen now is we'll also be on a Zoom, so myself and some other colleagues from the team. So if you'd like to join us and chat and ask questions just about Cloud Native and Node apps in general, or if you need help with the workshop, feel free to join the Zoom. Or alternatively, you can post any questions or queries you have in Slack. And if you do have any issues, please don't hesitate to message us in the channel, and we will try and help and work through them with you. With that, pass on to everyone to work through the lab. Hope to hear you in this Slack or Zoom. Bye for now. Hi again, everyone. I hope you all enjoyed the very quick overview of an introduction of cloud native development with Node.js. And I hope the workshop's going well for you all. Appreciate you may not have got through all of the steps just yet. So just to let you know, we'll still be on the Zoom and the Slack, monitoring it throughout the rest of the day. So if you want to spend some more time working on it and hit any more problems or have any further questions to ask us, we'll be around all day. So feel free to reach out and ask.
Yeah, great. Thank you so much, Beth. I really appreciate you taking us through this. And I will bop you out. So like Beth said, feel free to use the Zoom now and through the rest of the day. Feel free to use the Slack. We're all there and ready to help. And we're going to wrap this session up in just a few minutes and move on to the next session where we're basically going to take the work that you have here and deploy it to Code Engine, which is a really awesome service that IBM has that I think you'll find really useful. And so when we wrap up here, just a reminder, this stream will end, and in the conference platform, you'll just bop over to the next session. Sometimes these things kind of run into each other, but the way we have it set up, we'll bop in and out so that everything flows smoothly. So yeah, thanks for joining this session. Thanks again to Beth, and we will see you in the next session. Thanks, everybody. Appreciate it.